Creating static libraries .lib in C++. Let's begin with defining what we mean by a library. A library is a set of functions that can be used in one or more projects. Usually, it's used in more than one project. There are two ways you can create a library in Visual C++. The first one is called the static library. It ends with a .lib extension. This form of library is not specific to Windows or not specific to Visual C. This is the form of C runtime libraries. For example, the standard I/O, which has functions like printf, scanf. These functions actually are implemented in a static library that we get to use in every project we run. So that's the first example of a library. The second type, which is specific to Microsoft Windows, is called dynamic loaded libraries, or DLLs. They usually have the .dll extension. Using Visual C, you can actually create both number 1 and number 2. However, in this course, we will only cover number 1. DLLs are outside the scope of this course, which I will hopefully cover in future courses. The main goal of this course is to get you solid in C foundations, very strong and ready to move on to the next level. Okay, so now a question you might ask is, why do we even need to create a library? Let's take an example of one of the functions we have implemented, or we can implement, which is called reverse string. Typically, you would put the prototype of the function in a header file. Like in this example, let's call it reverse string.h. In that case, header file will contain the declaration of that function. This is saying that we're going to implement this function. Later on, we create the .c file that has the code that implements this function. This is just an example function that I want to talk about. So now let's say you have created this awesome reverse string function. As you start writing more and more applications, you realize that you need to use this function more often than once. So how do you go about reusing this function? One technique would be to always re-implement the function in every project that you create. But in that case, you're actually duplicating the code. And if later on you find out there's a bug in your code, you're going to have to go look for all the places you have implemented this function and apply the same fix everywhere. It's going to cause you some maintenance nightmare. Okay, so just to make sure that you understand what I just said in the previous slide, basically you have created a header file and a C file, and now let's say you have 3 projects here, project 1, 2, 3. In order for you to use the same code in every project, you're going to simply try to copy the header file and the C file into every single project. So that means you have 3 copies in this case. If you later find out that there's a bug in your code, you're going to have to go change it in 3 different places. If you want to actually enhance the code, improve it, then you have to go do it in 3 different places. So you can see why this is not a good way to do it. Another reason why you want to do a library is because, let's say these projects are not created by you, they're created by some other people. You don't want them to see the implementation of your code, but you still want to give them the function. Same thing with printf and scanf. We can use them in multiple projects, but we don't have the source code, or we don't necessarily need the source code. So that's why it's useful. You can give them the library. They just simply need to call the function and they don't have to worry about its implementation. So the takeaway is, you don't want to copy the code to multiple projects. There's a better way. So my recommendation is not to do this approach. Now let's talk about how do we create our own static library that ends with a .lib extension. So let's go back to our example here. The way we do that in Visual Studio is we're going to take our header file and C file and then go to Visual Studio and create a project. Let's say in this case, let's call it reverse string project. And that will be a library project. There's an option that's called static library, LIB project. And then we simply include these files in that project. So this project will be compiled using the Visual Studio environment. We can compile this project and generate as output the reverse string, the same project name .lib, which is the binary format, the binary code of the source code we have here. Even though you create the library file, anybody who wants to use your library, they would still need to have access to the header file. And the reason being is that at compilation time, the C and C++ language still would like to understand the function prototype. When you call it, it wants to make sure that the way you call it is actually compatible with the way it was implemented. That's why whenever you give somebody the library, they would still need to access the header file, but they don't have to use the C file. They can't see it. In the future, if you change this, you simply generate a new library, and then whoever is using the library can get the latest version and then compile with it. Okay, so just to clarify how we distribute the library, like I said in the previous slide, you still need to provide your header files as well as the library files to each project. Now there's two ways here again where you can do this. You can either choose to copy the header and lib file into each project folder. That's one approach. Or you can simply reference them using Visual Studio. You can add references to them into different projects. In both cases, you would still want to tell each project where actually to find these files. When you include the files, even if they were copied, you still want to tell the project, or you want to tell Visual Studio where to find the files when you compile and link with them. It's highly recommended that you get used to distributing your code as libraries instead of as source code. In the next lecture, we will jump into Visual Studio to see how we can create a static library together. Then later on, we will see how we can create other projects that will reference and use our library. Okay, so here I am in Visual Studio. Let's see how we can create our static library project. Go ahead and click on File, New Project. From the New Project window, make sure you have Visual C++, and then select Win32. We usually use the Win32 console application, but today we want to use the Win32 project, because here you can see it says a project for creating a Win32 application, console application, DLL, or static library. The last option here is the one we want to try out today. Let's go ahead and call this My Library. Click OK. On this dialog, we're going to click Next. On this page, make sure you select Static Library. And now we're going to uncheck the precompiled headers and the security development lifecycle checks. We don't need these. We simply want a static library. Go ahead and click Finish. Okay, so now you can see my library project has been created. It doesn't have any files in it yet. Next, we will create our library header file as well as source file. Right-click on Header Files and Add New Item. Make sure you select Header File from here. And then let's name this mylibrary.h. Click Add. And as you can see, Visual Studio has created the file here. mylibrary.h is now under Header Files. And it automatically knows its header file, so it added Bragma once. If you remember from the preprocessor directive section, we need this to avoid the multiple inclusion problem. So now you have a file that you can add your prototypes into it. Okay, next we want to create our source file. Right-click on Source Files, Add New Item. From this dialog, make sure you have the C++ file option, but make sure it's a .c, not a .cpp. The extension should be .c here. Okay, click Add. And now you can see my library.c is an empty file. It's been added under my source files. Okay, before we add any lines of code, let's compile this, make sure it compiles fine. To compile, you have two options, Ctrl-Shift-B on the keyboard, or from the build menu here, you can click Build Solution, which is the same as Ctrl-Shift-B. Click on this, it's now compiling. And as you can see now, it has compiled this project into my library.lib. This is the main difference between this project and the previous ones we used to create. With console application, you would have a .exe extension, an executable file. In this case, it's a .lib library file. You cannot run this, you cannot execute it. You can only take this code and add it to other projects that generate exe files. If you try to run this, Ctrl F5, it will tell you here unable to start this because it's not an application. This is not a valid Win32 application. You can add as many functions as you want to the library. It does not need a main function because that usually goes into an executable application. It's simply a set of executable functions that you can attach to other projects so that you can reuse the code inside the library. same as the C runtime, which is a library, same as many other examples of libraries out there. Okay, so now let's add a function. Let's assume we want to implement reverse string in here. To save myself from typing a lot of code, I'm gonna go back to my previous project here. It was called multi-file example. We created this with one of the previous lectures. I'm gonna click on that. I will select this function here. This is my reverse string function. I'm gonna copy this, right click and say copy, or also on the keyboard you can click Ctrl C. I'm gonna go back now to my previous project, my library, the solution. Make sure you're inside the C file, not the header file. Right now my file that's selected is the header file. I'm gonna click the C file to make sure this is the one that's active, and then right click here and say paste. Okay, so now I got the code in here. You can see right now there's a squiggly line on null because null is not defined. In order to define null, we should include at least one of the standard IO header files. Now null is not giving me a squiggly line because it's defined in one of the C header files. Okay, if I compile my library, Ctrl+Shift+B, there's a warning here that says strlen undefined assuming extern returning integer. In fact, we need to use string.h. So instead of standard IO, I could just say include string.h because strlen, the length of a string function, is defined there, and also that will include the header that defines null. Let's compile again to make sure this is fine. Ctrl+Shift+B. Okay, so now it compiled just fine. Alright, so now my library has this function, but still, if somebody wants to use it, we need to put the function prototype in the library header file that we're going to give to the users of this library. So go back to the C file, make sure you have this first line here, copy it, and include that in the header file. Paste it here, Ctrl+V, semicolon at the end. This is what's known as the function prototype. Inside your library, you can have as many C files and as many header files as you want. Just make sure that you would have a main header file. So this should be the main header file. You could have other files in here, not necessarily exposed to the outer world, that you can use internally. All that's important to the external users of the library is one single header file that exposes the interfaces or the prototypes inside the library. So what functions you want the users to be able to use, you would expose them here. In addition to some global constant variables, whatever macros, you can put all that stuff in here. And then this becomes the main header file of the library so that whoever wants to use it can include this file along with the .lib file extension, and then they can compile and run their code using this library. Click Ctrl+S to save it, or from here you can say save all or save icon, or even from the file menu there's a save option, save the file, save all, etc. Okay, so now my library simply has a single function in here, and that function is being exposed here. So now we compile it again, Ctrl+Shift+B. As you can see, now the library is successfully compiling. In the next lecture, we will see how we can create another project that can use this library and simply call the function here without having the source code. So see you in the next lecture. Using libraries in C++. In the previous lecture, we looked at how we can build our own static library using Visual Studio. In this lecture, we will build an application together that will use the library. So how do we use the library that we created ourselves? In order to use a library, you would need to have the header file, which contains all the function prototypes that you're going to use. This is needed for the compilation time because the compiler wants to check and verify the type of each parameter and the number of parameters, the function name, etc. So that information can be found in the header file you build with your library. So we would need the header file, and then we don't have to distribute the source code to every single application that uses the library. We learned from previous lecture that we can just build a static library, .lib extension, that will contain the compiled version or the binary version of the functions in the header file that we're going to include in our projects. So the first step is to include the header file, and then somehow we need to include the library file. That's the second step. And that is referred to as linking with the library file. When you include the header file and compile your application, you will see some link error. Whenever you see an unresolved function at linking time, that means compiler was not able to find either the source code or the binary of the function you're trying to use. And that's a link time operation. So that's why you would see at link time unresolved external errors. In order to resolve that, you would have to include the lib file. There will be multiple ways to include the lib file. I will show you that in the program we're going to build together. One of the ways is by using the pragma comment. I'm going to also show you that. And there are other ways where within Visual Studio or the command line, you can specify additional dependencies and library directories. Let's jump into Visual Studio to see how we can use the static library we built in the previous lecture. Here I am on Visual Studio. If you remember from previous lecture, we actually built my library. Let me just quickly remind you of that. Inside my library, we have two files, mylibrary.h and mylibrary.c. Mylibrary.h simply has one function for now, which is enough to demo this functionality. So we have defined a reverse string function and also implemented that in mylibrary.c. And once we compile this, we will get a .lib here at the bottom. Already compiled. Let me recompile, rebuild solution. So as you can see here at the bottom, it's called mylibrary.lib. So this is what we need to include in our project that we're going to build so that we can use this function. So in order to use the reverse string function, we will need the header file and the lib file here. So let's go ahead and close this solution. And then now let's start by creating a new project. Click on File, New Project. And now we're going to make sure that we have Visual C++ 132 selected. Now we're going to create a console application. Let's call it Reverse String Demo. Click OK. On this page, we click Next. Make sure you have an empty project selected and then hit Finish. Let's add our main.c. Right click on Source Files, Add New Item, and let's call it main.c. Then click on the Add button. Okay, so now what we want to do is we want to see how we can do something like this. We have a string. This is a test. Now let's see how we can actually printf reverse equals %s, and then we want to call reverse string function that we built in the library. As you can see right now, this is not defined. If I try to compile, I'm gonna get like here some errors because this is not defined. We know that we have created this in our previous lectures, so how do we include it in here? I'm gonna show you now a technique where you can include the header file and the library directly in the same project. The first approach we're going to use is by simply copying the header and the .lib into the project, which is not recommended, but I still want to show it to you. So let's go back here and look at our main library. Let me open that folder where we have the main library. So I have here my library folder open in the Explorer window. It shows you the solution and the subfolder for the project. As you can see here, there's also a debug because we compiled it as debug. If I click on that, there's the library.lib file. In fact, this is not clear. Click on View and then say Show File Name Extension. And now you can see it has the extension file showing here. So my library.lib is one of the files we want to copy. So I'm going to copy this one. Right click, copy, and then back to Visual Studio. Right click on the tab and say Open Containing Folder. This is where this file currently resides. I'm going to paste that .lib into here. So paste it. Now I have my library.lib. So I'm showing you how to do this by copying the files, which in a previous lecture I mentioned this is not really recommended, but I still want to show it to you so that you can understand how it can work. And then in the next attempt, we're going to do a much better approach. We keep improving the approach until we get to the final recommended approach. Okay, so now this is done. Okay, so I'm going to go back here, back to the project so that I can copy the header file too. Right click, copy the header file. and then come back to this reverse string demo application and then paste the header as well. Okay, so with this step, we have copied the header and the lib file here. So back in Visual Studio, we're gonna include with the quotation marks. Immediately it shows up my library.h. And if you want to actually open it, you can right click on it and say open document. This has the function prototype here. Okay, back to main.c. So now we simply have included the header file. Let's try to compile. Ctrl+Shift+B on the keyboard. Now we have the link error that I mentioned before. It says fatal error, hit F1 on this error. It will show you more details. But basically what's happening here is that there's an unresolved external reverse string, because we simply say we claim we have a function called reverse string, but the compiler could not find the source code or the .lib for that function. Okay, so now how do we bring in the library into this project? There are multiple ways. The first technique, you can right click on the project here, and then you can say add existing item. This is one way to do it. And then it opens up this add existing item dialog. As you can see here, I have my library.lib. I'm gonna include it by clicking on add button. And now it shows up here. As you can see, it shows up as part of the project. So now if I compile again, if I click on build solution. Okay, so now we have successfully compiled an exe. So this technique allows you to link with the library. Let's run this, Ctrl F5. As you can see now, this is a test is being reversed. Okay. So this is one approach. Let's delete this from here. Right click on it and remove. Do not delete because that will delete the file. Just simply click remove. This will remove it from the project itself. Okay, so now let's verify it's been removed. Ctrl+Shift+B to compile. I should get an error again. Okay, so now we're getting the same error, unresolved external. Now I show you the second technique to add it. Another way to add it is by using --pragma comment lib, and you just give it the my library lib. This works for any library as long as the pragma comment can find the path to this file. Since it's in the same folder, this is going to be quickly found in the same folder. The pragma comment can be used for multiple things. One of them is the library, which means include this library as part of the project. Basically, this means link with this library. So let's compile this, Ctrl+Shift+B on the keyboard. Now you can see here, it's actually successfully compiling. We can run it, same output, okay. So this is the second technique. If we comment out, compile again, Ctrl+Shift+B, we get the same error again. Okay, so this is the second approach. A third approach, typically what people mostly use in C and C++ development, you right click on your project here, click on properties. This will bring up the project property pages. In the Visual C++ directories, you have library directories here. We're not going to use it now because the file is local to our project. We're going to go to linker, and in the linker section, if you expand it, there's the input section here. As you can see at the top, additional dependencies. So additional dependencies, basically, you can see kernel32.lib, user32.lib. These are libraries built by Microsoft for the Windows operating system. GDI for graphical device interface, WinSpool, common dialogues, etc. So these are additional dependencies that if you use in your program, they can be linked with your program. So now we want to add our own. So now I'm going to click on additional dependencies, expand it, and then click on edit. And here I can simply say my library.lib. Let me zoom in so you can see I've typed my library.lib here in this additional dependencies dialog. Now I'm going to click OK and then click OK on the page to close it. Let's compile this and see. Ctrl+Shift+B again. As you can see here, it's successfully compiling. And run it again and it's working fine. In this lecture, we learned how to use a library we created together in a project by including the library.h and the library.lib files. However, you should never have to copy the files into every project that you use. There are better ways that we're going to explore next. But I just wanted to make sure that you understand if for some reason you need to do this, this is basically how you can do it. In the next lecture, we will look at a much better approach by not having to actually copy every time. So see you in the next lecture. Using libraries in C++, Part 2. In the previous lecture, we looked at how we can use a library that we built by including the header and the .lib file in our project. This lecture will focus mainly on how we can use the library by placing it in a specific folder the same way we do with third-party libraries, like libraries we buy from other people or open source libraries. What if there's a library from Microsoft or from some other company that you want to use? These libraries usually get installed into a special folder, maybe like an SDK folder, some folder that is usually in the path. Let's imagine that you want to distribute your library to some other people, some other developers, and you create your own installer that will place the files inside a certain folder that you create, some folder of your own. So let's pretend this is the scenario we want to try out. So let's jump into Visual Studio to figure out how we can use our library if it was installed into some folder on our system. Okay, so here I am in Visual Studio. Just to remember from the previous lecture, we had created the MyLibrary project, and we also created the reverse string demo. The MyLibrary project contains just one function, which is reverse string function, and then the reverse string demo is basically a client, a user of that library. So let's open up the library, click on the library project. Okay, so this is our library. It contained mylibrary.c with the implementation of the function, and also the mylibrary.header file. To make sure this is compiling fine, we can click on the build menu and rebuild solution. This will clean the solution and rebuild from scratch. Okay, so as you can see here at the bottom, it's created mylibrary.lib. So in this lecture, we want to see how we can copy mylibrary.h and mylibrary.lib into a specific folder on our hard disk, and then pretending that this is installed by an installer we create. We're not going to go into how do we create our own installer here. We're just going to assume an installer has copied these files into a certain folder. So right click on the solution file and then click on Open Folder in File Explorer. So this brings up the File Explorer on that solution folder. Since we're building debug here, the output is going to be a debug folder. There's two files inside, mylibrary.lib and mylibrary.pdb. The PDB file is the program database file. This is mainly used by the debugger to actually allow you to step into the code and debug in case of some runtime errors. This will have the symbols built by the compiler so that the debugger can look into this and can give you some meaningful information. On the call stack, you will see the function names, the name of the parameters, etc. If you distribute the debug version with your library, then there will be too much information that somebody could reverse engineer your code. Typically, we don't do that. We only do smaller PDB files with the release version that contains some simple information to help debugging and troubleshooting issues with your code. Let's forget this for now. We're going to focus on our lib file. This is the binary file that contains the generated code for the functions that we created. So this is actually the executable code that can be linked with any C++ program so that it can use the function here. So I'm going to copy this file, right click copy, and then I'm going to open up a file explorer again here, another window, and I'm going to go to some folder on the C drive. Let's create a new folder, and this new folder is going to be called, let's say, my library. You can call it whatever name you want. I'm just going to call it my library here. Now I'm inside C my library. I'm going to right click and paste the .lib file here. You can either copy the files directly here, or typically people would create two subfolders, one called something like bin or lib. Maybe we can call it lib here. And then inside the lib folder, we're going to paste the mylib file here. So now let's go back up one folder. So you can see my library now has a subfolder called lib. Next, I'm going to create a new folder and call that include. And then inside this one, I'm going to go back here to my library again, and then click on the project folder. You can right click and copy the file, as one option, or you can hold the control key on the keyboard and then try to drag this into here so it says copy to my library. In fact, I'm gonna copy it inside include. So that's what I'm gonna do, copy to include. Now if I double click, it's actually already copied here. Make sure you don't delete the original file, just copy it here. So now on my C drive, there's a my library folder, has two subfolders, include and lib. Include has the header file and lib has a .lib file. A typical installation from some third parties might look like this, where there would be like company name / product name. Inside that there will be subfolders where they have include, lib, examples, binaries, etc. So I'm just trying to show you how, if that was the case, how we can use a library like that in our projects. Let's go back here to Visual Studio. Let's create a new project, file, new project. Okay, let's make sure you have Visual C++ 132 selected from the list, and then make sure you also have console application selected, and let's call this reverse demo 2. Click OK. Click next on this page, and then make sure you have empty project selected and then hit finish. All right, let's create our main.c. Right click on source files, add new item, and then let's type main.c, click add. Okay, so in this demo application, we're going to see how we can include the library, given that it's now inside a special folder that we created. And just like the previous demo, we have our main function here with some string that we want to reverse and display out on the screen. So we have created this folder called my library here that has two subfolders. Let's see how we can connect that to Visual Studio. First thing is we want to bring in the include file, my library.h. We cannot use the quotation because that file doesn't live in the same folder as our C file here. However, we can still do something like this, which is highly not recommended, where you can say my library, and then you can say include, and then you can bring it in here like this. I think it's okay to do it either way. So one way you can do that is by saying include the full path to the file, which is not recommended at all. I don't recommend that you do this. If you're part of a team that wants to use the code, then maybe another developer has copied this library into an E drive or a D drive, etc. This is not gonna work for everybody. They might have like SDKs folder, they copy it inside the SDKs folder, etc. So this is not portable code, right? This code is not portable. What if somebody wants to try to copy this into a Linux or Mac? Do we use a different path? So this is not portable at all. Don't do it this way. Instead, we want to utilize the power of the compiler and the editor that we use, Visual Studio in this case, to help us figure out where this file lives. We could simply do something like this. Now the include is not going to be able to find the file. If you right click and say open document, it will not be able to find it because it's searching for the file in the current locations. It's not part of these. So how do we fix this? How do we tell Visual Studio to go find this? If you remember from previous lectures, we talked about the additional include files. Right click on the project and go to properties to see how we can fix this. In here, we have the Visual C++ directories. There's something called include directories here. Path to use when searching for include files while building a project. This corresponds to environment variable include. So this is one location where you can fix it. There's also under C++ an additional include directories. This also specifies one or more directories to add to the include path, separate with semicolons if more than one. So this is the same as the /i on the command line. So you have one of two locations to specify this, either the include directories or the additional include directories. Also, you need to notice that these values are specific to a certain configuration, whether it's debug or release, and also it can be specific to whether it's Win32 or x64 or all platforms. I encourage you to do it for all configurations and for all platforms so that you don't have to worry about this when you compile debug versus release, 64 versus 32. etc. So you should actually make sure that you select all configurations, all platforms before you change any of these values. So let's use the include directories here. Click on the arrow to expand, click on edit, and now we're going to say an additional folder would be, in this case, / without the drive my library #include. So this is one way to do it. Some people might put here the C colon. I'm gonna leave out the C colon just so that it says this is on the root of the same drive that we have the project on. Click OK. So now include directories are gonna include the following values. And then in addition to all of that, is going to include mine here. Make sure you hit apply or OK so that this gets saved. Click apply. Now OK. Let's now try and see, verify that this is now accessible. Right click, open document. So now it can open the file. As you can see, the file has been opened. Okay, that's good. So that's the first step. This will take care of the compilation problems. If we want to compile now, Ctrl+Shift+B to compile. We're going to get one error as expected, which is that we're referencing an unresolved external. If you remember again, the linker now is trying to figure out where's this function reverse string is implemented. It cannot find the implementation, so that means we need to link with the lib file. The first one that I'm going to show you here is again by using the project properties. Right click on the project, click on properties, and now we're going to go to the directories again. The second one we want to look at in addition to the include is the library directories. So make sure again you have all configurations, all platforms. Let's expand this, click edit. I'm going to add a new value, which is / my library and then lib. So once I do that, then the editor and compiler will understand that there's a new path here that they need to look into for libraries. So click OK to save this. Okay, now that's going to take care of where to find the library. However, we still did not tell the Visual C compiler which library contains the implementation of this function reverse string. So there's two ways now we can do that. The first one is by saying pragma comment, if you remember, library, and then you can specify it's called my library.lib. This is one way to do it. Let's verify this is going to work. Ctrl+Shift+B to build. And you can see here now I'm successfully generating the exe. We can also run it to verify. Ctrl+F5. As you can see now it's running fine. So this is one technique to use the pragma comment. So this is just one approach. Other techniques include specifying the same library inside the properties here again. Right click on the project properties, and then let's go to linker. Remember that was a link error. That means we have to go to the linker to tell the linker where to find the library. So if you expand the linker section, there's the general options that you see here. And then there's the input section. The input section has additional dependencies. So this one specifies additional items to add to the link command line. And as you can see right now, by default, you're actually linking with a lot of stuff that we don't actually use. But I think the linker is smart enough that it won't bring in any function that we do not actually use. In our case, we simply need to include my library.lib. So now I'm just double checking my library.lib, click OK. Now you can see here, it's been added to the additional dependencies. Click OK. And now this is commented out. Let's verify this is gonna compile. Ctrl+Shift+B. As you can see, it's now compiling file. I did not specify the full path to my library.lib. However, Visual Studio is smart enough to go look for it in the additional libraries path that we specified. So that's how it knows where to find it. So this is how we basically would do it. We would treat our file here as if it's coming from an external third party like standard IO here. And then to link with the library file, you have one of two options, either the pragma comment or the project properties here. And then you go to additional dependencies. Okay, so that's it for this lecture. Using libraries in C++, Part 3. In this lecture, we will look at how we can use multiple projects in a single solution, and also how we can utilize that to reference our library from another project in the same solution, and then learn about project dependencies. So let's jump into Visual Studio. Okay, so here I am on Visual Studio. Go ahead and open up our library project. Click on File, Projects and Solutions, and find the My Library solution. In my case, it's the first solution here, so I'm going to click on it. Okay, so now it's open. In today's lecture, we will see how we can add a second project to our existing solution. Right now, the solution has My Library project in it. So we can collapse and expand it. So you can see in this solution, there's right now one project. To add a second project, we're going to right click on the solution and click on Add New Project. This is one way to do it. Another way would be to click on File, New Project. But when the new project window pops up, instead of creating a new solution here, we can simply say Add to Solution. And that way it will add this new project to this current solution. I'm going to cancel out of here and just do it the other way. So right click on Solution, Add New Project. Make sure that in the new project window, you have the Visual C++ Win32 selected, and then let's create a console application. I'm going to call this Reverse Demo 3. Click OK. On this page, we're going to click Next. And now I'm going to select the empty project because it's a C project. Click Finish. Now you should see inside the Solution Explorer window two projects, My Library and Reverse Demo 3. Expand Reverse Demo 3, then you will see the content of this project. So right now there are no source files, no header files. We're going to create our main.c by right-clicking on Source Files, Add New Item, and we're going to call it as usual main.c, then click Add. Notice that main.c is added to the Reverse Demo 3 project, not to the library. Just like we did in previous lectures, I'm going to simply #include standard.io.h, then say void main equals reverse this for me. We're going to say printf. We're going to have to call reverse string function and give it our str here. Alright, so this is our Reverse Demo 3 project, and I'm trying to use the function reverse string, which is defined inside my library. So the first thing we want to do to make this compile successfully is to #include mylibrary.h. As you can see, the compiler doesn't know where mylibrary.h lives. Even though the other project is in the same solution, it still doesn't know how to get to this file. If you try to open it, you will get an error here. Same thing as we did before. Now we need to tell the compiler where to find this header file. We're going to right click on my Reverse Demo 3 project, click on Properties, and make sure that you have all configurations, all platforms selected, so that whatever we change here is going to apply to all configurations, all platforms. If you click on Visual C++ directories, there's the include directories here. Another way to do this is to go look for additional include directories under the C++ category. There's an additional include directories. This time I'm going to use this one. Even though include directories or additional is the same, I'm going to just use this one here because I showed you in a previous lecture how to do it with the include directories. In this lecture, let's just pick the additional include directories. Click on this arrow and then click Edit. And now we want to specify that inside my library is the header file. So how do we do that? I don't want to hard code the path to my library. I don't want to do this. If I click on this here, select folder, this will be hard coded path. I don't want to do it this way. So let's delete this one. What I want to do is utilize some of the macros inside Visual Studio that can help us actually refer to my library. So if you click on this button here, it will expand and show you. We can expand this dialog even more so that we can see exactly the values of these macros. I can search for the word my library to filter down to the possible macros that can have this value. One of them that's interesting to me is, if you look here, there's the solution path. This gives you this value. That's not what I want. I want the solution directory. If you look at the solution directory, this is the macro name and this is the value that it expands to. If I use this macro, this is the value it will give me. If I look at that, you can see it's actually the full path to my library, which is this directory here. So that could be one of the macros that I want to use. So I'm going to use here $solution dir. And if you notice, the solution dir actually ends with a backslash. So that means you don't have to specify backslash in here. Just to make sure that you understand what I'm trying to do, I'm going to try to open this up. I'm going to hit OK for now. Close this down. If I open this in File Explorer, you see my library.h is in this directory. Here's the full path. So one step up, if we go up one folder, this is the solution dir value that we have. Inside it, there's multiple subfolders. The two ones that I'm interested in are my library and the reverse demo 3. Reverse demo 3 has our main.c. So from main.c, I want to say include the file, go back here up, that's inside this directory. So inside the solution dir, there's a subfolder called my library. Inside this is the header file. Okay, so given this information, I'm going to go back here again. I'm going to right click on reverse demo 3 again, properties, and change the additional include directories. Edit again. So back to this one. If I expand again, you can look for solution dir. As you can see, that's the only one here. So it actually ends with my library. I want to also say my library here, which is another subfolder inside this. So it's actually going to concatenate the two together. You can also add a backslash separator here, but even if you don't, it's okay because as you can see, there's one here already. So this should be fine. Click OK and then click apply or OK again here. Once we do that, you can see the red squiggly is gone. I can verify by opening this document. Now it opens up my library.h. So that means the path is actually correct. Cool. So this now should compile fine. Control-Shift-B. It should just compile. And as you may expect, there will be an error, which is a link error, unresolved external reverse string. We claim we have a function called reverse string, but the compiler needs the code for that function. It couldn't find it in here. It found the prototype, but even after compilation, it cannot still find it. So that's where we need to add the lib file. So one thing we could do is we can again say pragma comment lib and give it my library.lib. But if we do that, you will still have to tell the compiler where to find my library.lib. We have to go change the additional include libraries so that the path for include libraries should be also changed so that it can search for this inside my library folder. So if I compile now, it's not going to work. As you can see, cannot open file because it cannot find it. So I'm not going to use this technique. The fact that we have this as part of the same solution, there's an advantage to that. And I want to show you the advantage. You can go to your reverse demo project and then right click on references and say add reference. And now you can add a reference to your current project by choosing one of the existing projects inside the solution. So there's my library here. If I check this, that means I want to reference this inside my project. Click OK. And now you could see that under references, I have my library referenced inside this project. Once you do that, you can simply compile without having to specify where the library is. So Ctrl-Shift-B to compile. As you can see now, we are successfully building the exe. All right, so that's the advantage of having the two projects in a single solution. You can now reference multiple projects from the same solution. Another advantage is that if you click on projects, there's a project dependencies window here. This will show you that reverse demo 3 depends on my library, and that dictates the build order. So you can see here, my library is going to be always built first, then reverse demo 3 will be built afterwards. In fact, we can see that if we go back to our library and make some changes, if I click on my library.c, let's pretend I want to change this. Let's add a comment here, comment. So once I do that, I'm going to compile, Ctrl-Shift-B, and now you can see it compiles both the library and the program because it knows that in order to build the program, it has to recompile the library. The advantage of this is that whenever you change your library, then automatically it will apply the changes and you get the latest version linked with your other programs. Last thing I want to talk about here is that if we zoom in here, you can see that the name of my library is actually boldened, whereas the reverse demo 3 is not bold. There's a concept here, which is in every solution, there's always one active project. Right now, the active project is my library. In fact, if I try to run Ctrl F5, it will say I cannot start my library.lib because it's not an executable. So Visual Studio Assembly acts on the active project, which is my library in this case. In order to make reverse demo the startup or the active project, you right click on it and then you say here set as startup project. So now you can see that reverse demo 3 is actually bold, whereas my library is no longer the bold one. Reverse demo 3 becomes the active project. So now if I run Ctrl F5, it will immediately run my console app. So if you have even if you have 3, 4, or 10 projects inside the solution, there's always one project that's the active project. Its color is more bolded, it's more white. You can always go back and set any project as the startup project. Just remember, when you do that, after you close the solution and reopen it, it will always remember the active project. So see here, it will always remember the last active project, which is a nice feature because you don't want your library to be the active project. You probably want the executable to be the active project. And then whenever you run, you debug, you're always working with the active project. So that's it for this lecture.